We're going live, and we are extremely live, and we are extremely well dressed today, among other things. We're also very well prepared to give an amazing session. Hi, everybody. Welcome to the Data on Kubernetes community. Today, we're doing an extra special student session with the CNCF Students Group. Shout out to them. My name is Bart, Farrell, if you didn't know that already. And why am I wearing this amazing hat, you might ask? Well, for a couple of reasons. First of all, I'm a very fashionable individual, as you probably already know. But secondly, there's another hat that will be featured later on the presentation, but I don't want to give any spoilers away. But just be prepared to have your hats on, take your hats off, wear sunglasses if you want. As a quick reminder, I just want to let everybody know while you're here that you can sign up for the DoK day that'll be on October 12th. You will also be able to sign up very soon for the DoK Students Day that'll be on October 6th. We've got a lineup of over 25 speakers. It's going to be a very intense day. It's going to be on October 6th at 3 p.m. my time, which is 6:30 p.m. in IST and 9 a.m. where Derek is. Speaking of which, Derek, this is not your first appearance in the Data on Kubernetes community. You were with us last week on Friday, where we shared an experience not only with difficulties on Twitter Spaces, but then we were hacked on Google Meet. So that's a lot to go through on one Friday. But anyway, very nice to have you with us. Can you just introduce yourself and let everybody know what we're going to be talking about today?
Yeah, absolutely. Thanks a lot, Bart, for having me. Thanks for letting me join. I'm definitely excited to be here with you. As Bart said, I'm Derek Downey. I'll have an about me slide in a second. I am a Google engineer, DevRel. But today I'm going to be talking about data on Kubernetes. Kubernetes has been a thing for a few years now, and it's kind of starting to leak into the data space. So I have been a DBA, and I've titled this talk, "What's a poor DBA to do?" So I'll be talking about having a bit of empathy for your DBA and the DBA who's just trying to figure out how to DBA on Kubernetes. So that's what this talk is about.
Very, very good. I don't think we can ever have too much empathy when approaching data or Kubernetes, and certainly when we're putting both of them together. So I think that's good that people understand that the DBAs are not the villains of the movie, if we want to call it that. And like you said, to really keep that empathy basis in there. Just as a reminder to everybody who's in the audience, please leave your questions in the chat on YouTube. We will get to them accordingly during the talk. There's going to be time for Q&A, additional time for Q&A, and also a bit of a demo, but I will leave that in your hands, Derek. So if you'd like to share your screen, go for it.
Great. So let me get this screen shared. You may have seen me drinking a big giant mug of coffee on camera. That's kind of what I need in the morning. So where's that share button?
Perfect.
All right. So
gotcha.
Yeah. Data on Kubernetes. What's a poor DBA to do? I'll go ahead and get started.
Yeah.
So yeah, I'm Derek Downey. Currently, I'm a developer advocate at Google Cloud. I guess I'm not really a DBA at the moment because of that. But I say once a DBA, always a DBA. So as a developer advocate, I do get to talk about my favorite topic, databases. Generally, that's Google database products, but today it's more about the industry of databases. So another thing that I'm not is a Kubernetes expert. So it's kind of odd that I'm on here talking about Kubernetes. But my current focus at Google is on Cloud Spanner, which utilizes a technology called Borg. And Borg is a predecessor to Kubernetes, but I'm still no expert in either of those. I know enough to be dangerous, so this should be kind of fun. Speaking of hats, I'm going to go ahead and put on my Noogler hat. A Noogler, if you're not aware, is someone who recently joined Google. So I may look kind of funky wearing this or weird, but that's fun. So I'm doing it for mainly two reasons. First, like I said, is to have fun with the talk. And second, it's a reminder that learning and doing new things is always important. So as a Noogler, I'm doing new things. In the talk, I'm going to explore a bit about what the big deal is about Kubernetes, right? This will be colored by my perspective specifically as a DBA. Then we'll jump into having a DBA pity party, where I will explore the criticality of data and the types of tasks a DBA might be asked to perform to protect that data. And then we'll start to get a look at how those tasks change or go away with running the data environment on Kubernetes. So we might even add new tasks that are required when running on Kubernetes. And so finally, we'll have time for a demo where I will put on my DevRel hat again and walk through running a MySQL operator on GKE, which is Google's Kubernetes engine. We'll look at the design doc of the operator to apply some of what we talked about, and then we'll go ahead and run it. I find this is kind of an interesting way to get a different perspective of running kind of a basic setup. And then to conclude, we'll go ahead and answer the question, what's a poor DBA to do? So, like I said, Kubernetes is a really popular product. It's probably safe to say that it's here to stay and it's worth learning. This is important for a DBA. We don't really like to go learning new technologies if they're not going to stick around. So let's explore why Kubernetes is here to stay, because Kubernetes itself is a fairly complex product, and generally complicated things are really hard to adopt and to implement. So if you are a developer, I imagine you don't want to think too much about the underlying infrastructure. You make requests and expect responses. Then you process the responses and in turn send responses to the client. Nice and simple. Sure, you may choose what the data store you use or what caching layer, but the details of how those are managed aren't really important to you as a developer. So you have a nice black box for your backend infra. But if you're in operations as maybe an SRE or a DBA, you have to worry about the infra. It's not a black box. In fact, it's kind of a complicated mess of many, many moving pieces. And management for each layer can be different. And all of these services on the screen are underlying by different resources, right? And like I said, complexity is bad usually because it increases the likelihood of issues, whether those are outages and downtime or just plain old mistakes.
Real quick question there.
Yeah.
Considering that you have a lot of experience as a DBA, could you talk a little bit about the working relationship between DBAs and SRE, site reliability engineers?
Yeah, so traditionally or currently, right? So traditionally, like DBAs were the guardians of the data. They do not let too many people touch it. So DBAs may have to ask your SREs or your sysadmins to provision the resources, but they manage the resources. They put in the processes to make sure that they're safe and secure and only certain people have access. And I'll talk a little bit later about why that came to be because of data criticality. But DBAs are definitely on the side of the operations side, but they're like a segregated thing. Like they put up walls and they protect their data, like almost like gatekeepers, right?
Okay.
So there were very strict silos. Those silos are kind of starting to break down with technologies around automation and with like things like Kubernetes, which is a great thing. So it also is putting a little bit of the burden on the DBA to pick up some of those operations hats, basically, right?
All right. So good. Thank you.
Yep. So when Kubernetes comes around, the promise of it is that it brings all of that infrastructure into something that's more manageable for the operations by providing some sort of management framework that works with disparate systems. And so this theoretically allows developers to request the resources they need for the services, and it doesn't add too much overhead on the operations team because they have this framework to provision these resources, a way to define the resources as well. So what you end up is that the reality is that Kubernetes simplifies the management of these specific services. It provides a nice consistent framework that allows you to be really efficient with your compute resources. Stateless services are easily moved around on the underlying hardware, and individual components or services can scale up or down as needed. Of course, the operators will need to learn how to manage a fleet of resources using Kubernetes, but at least they have this consistent framework. And again, that was great for stateless services, but as this diagram depicts, the stateful services are kind of left out or have been traditionally from Kubernetes. These are services that require persistent data. And so why is data treated kind of like a snowflake in these cases? So to explain that a little bit, I've created a really simple diagram of what a database server traditionally has. Specifically, it's the resources that the database will need. You have CPU, you have memory, and disk. Not shown here is networking. That's kind of the fourth resource that a database needs. Obviously, a database needs networking or they're kind of useless. But it's important to know why but the networking is not important to know why data is a niche problem on Kubernetes, in my opinion. The biggest problem is that the interaction with the storage. Database applications generally map storage into memory or pull the data from storage into memory before it can work on it. As it works on the data, then it can make changes and it flushes those changes back to disk. So most databases today were designed to be very tightly coupled with the server resources, specifically the compute of CPU, RAM, and then the storage as well. So you can see that really in the rise of virtualization. Even still, as I mentioned, the DBAs would ask SRE or sysadmins to provision resources. Well, even in virtualization, they fought for dedicated hardware for the databases, not just virtualized environments. And most of that was to ensure that you had consistent performance of the data that's not stolen by some rogue application, maybe Java application eating all the memory, right? So they really needed to get consistent performance, and to do that, they needed to be very tightly coupled with those server resources. So if you now put the database on Kubernetes, which makes no guarantees about where it's located and how it accesses the disk, there's really no way that the database can operate safely. Luckily, persistent volumes arrived and solved the bit about tying the database pod to storage, which is why we're able to have this conversation. But there's still a problem. And so to understand that problem, we got to remember that the databases pull data from storage into memory before performing the work on the data. So if you move your compute resources, your CPU and your RAM to a different host, then that data is going to need to be pulled back into memory before it can be worked on. This will cause any extra performance issues anytime that database pod is relocated. So basically, I'd say Kubernetes is great for stateless workloads and helping simplify the management of the many moving pieces. But anytime you need to tie that data into memory and then reload it somewhere else, this is one of the reasons why data is slower to adopt into Kubernetes. So I've been involved in many performance-related incidents where the question was asked, why is the database slow? So because of that and the complexity of Kubernetes, I would be hesitant to put business-critical data on anything that could cause problems with that data. Unknown processes that could cause those problems, right? So speaking of that, it's time for our DBA pity party.
Oh, and with that in mind too, could you give an example of, like, when we talk about business critical data, what would be some examples of that?
Yes, I will do that in a second.
Okay, good. I'll be quiet then.
Yeah, no, it's a great question.
Okay, that's all good.
So I should note that I'm generally speaking about the DBA role as a whole. Some organizations are large enough where you have operational and application DBAs, where application DBAs are focused more on the queries and the schema, and operational is like on HA, security, things like that. I'll be addressing the tasks for both of those roles. And so speaking of the statement that data is critical to businesses, this has really given me a pretty good career so far. It has led really to businesses being very careful with the data and being conservative with adopting new technologies like Kubernetes. Why is data so important? So I definitely believe that data is critical to businesses because people hire DBAs to manage their database. It has an entire job function around it. You can't just take my word for it, though. Linked in these slides, which I'll make available after this talk, is a Forbes article from 2019 that indicates the global market for data and data analytics will be $135 billion by 2025. These are products that companies are creating services, or like the cloud vendors are creating products around data and data analytics. So people are spending money upwards of $135 billion by 2025. Now, COVID may have impacted these numbers somewhat, but it's still kind of staggering. And to understand why it's so big of a market, well, the first reason is that businesses rely on the data to make decisions. Decisions that they're making on this are whether their product is a fit for the market, are they getting a lot of traction, or do they need to pivot and do something new? What features should they prioritize based off user activity or requests? Which products should they stock? Which ones should they remove? Or is it a seasonality thing? So data really helps drive business decisions to maximize their revenue, right? The second reason is that the businesses wouldn't really have the data if they didn't have users. So the users hate when their data is lost. The traditional example of this for a relational database is a banking application where you've transferred your money, but then that data was lost, and then you've lost your money in the transaction. That's kind of old and boring. So imagine as a gamer, having to redo all of your efforts on your leaderboard if some of your actions got lost. Or what if the super important post that you shared on your social media site suddenly went missing? We now have a scandal around censorship. We don't want those. So users really care for their data across really all industries. Let's see. What happened? I clicked my link. Let me go back into full screen mode.
No problem.
I don't know how I clicked my link. Anyway. Okay. So anyway, data loss is costly for the company. So obviously, if you have a poor user experience of losing data, it will result in users leaving and your declining revenues based off that. Another reason, though, the data is costly is ransomware. Ransomware is on the rise. As an example, and this link that I accidentally clicked is back in May this year, there was a gas pipeline company in the US that had a ransomware attack on it. It definitely impacted the gas prices in my area. And what happened was they weren't able to restore the data, so they had to pay this ransom of $5 million to get their data back. So it's not just costly from users leaving and not trusting their service anymore, but it's also from a hard dollar amount in paying for ransomware if you're not protected. Yeah, so finally, mistakes of any kind do take time to fix. And that the time to fix a mistake is downtime that results in lost revenue. So when you've involved data, it takes longer to do that, primarily because of physics. It simply takes time to restore the data. The larger the data, the longer it takes. That kind of makes intuitive sense, right? So yeah, that's why DBAs exist, to protect the data. I like to say that DBAs are guardians of the data, which is a shift, a guardian instead of a gatekeeper that I mentioned earlier. So what type of tasks do DBAs perform? I personally believe that this would be a crappy student talk without a Venn diagram, so here we go. The main categories of tasks that a DBA spends time on while guarding the data is availability, security, and performance. On the availability side of things, we have disaster recovery. It takes up a large amount of upfront planning and testing, continual testing. This really includes anything from restoring from users dropping data accidentally or on purpose to hurricanes wiping out the data centers. The security kind of takes up that data encryption, whether at rest or in transit, and data compliance. Compliance will be things like GDPR in the EDU, HIPAA for US health information, or PCI for credit card data. Performance is a big scope, and to put config management here is a small piece of that, but that's really performance for the running databases around configuration. But of course, there are overlaps in certain segments. So for performance and availability, we have schema management, whether you're adding indexes or changing column types or adding new features. That will affect the performance and the availability of the data. You have capacity planning to make sure you don't run out of resources to serve the demand. So those type of tasks are being done as well. We have backups and restore testing to recover, but because you're saving these backups of your data somewhere else, there's a security component to making sure that those are safe and not accessible. And then user management to make sure that people have the right accesses and not too many access privileges. And then we have data pruning and query auditing, which covers security and the performance. So making sure that you're only keeping the right data that you need will also allow your database to use less resources and perform a lot better. So those kind of concepts span security and performance. And then finally, we have patching and upgrading and various troubleshooting. These last two tasks hit on topics from all three of the availability, security, and performance. So that's a lot that a DBA has to do while protecting the data. And now we understand, hopefully, why there's a full-time role around it. So with all DBAs are asked to do, we're now asked to move that data that we need to protect onto Kubernetes, which is a very complex piece of software that we don't necessarily understand, and we don't like the fact that it's a black box. So if you recall our developer experience, backend infrastructure is a black box to the application, but the reality is that our database is the application as a DBA, right? So we're not actually programming the application, we are managing that application on Kubernetes. And I need to know how to manage it. And so I either have two choices. Do I treat the backend as a black box, the Kubernetes infrastructure as a black box, or do I go ahead and learn how to operate Kubernetes? So you're not going to learn how to operate Kubernetes here in this talk, far from it, because I'm not an expert. But I'll go ahead and address some of the considerations framed from the perspective of our three categories of availability, security, and performance. For availability, we basically have three different concerns: connectivity of the application to the data, recovery of the data, and then the durability of the data. For connectivity, if anything breaks on these solid lines, then data access is at least impaired, if not completely unavailable. It's important that each element of my stack is highly available. So I have additional database servers, or I have, or in this case, database pods, and I have a highly available proxy layer. And it's important that those replicated pods are on different hardware so that if one node piece of hardware goes down, it doesn't take down all of them. So that's kind of the connectivity piece. For recovery, both from the method of taking backups and recovering them, these are going to change when you're running on Kubernetes just slightly because of the way you're going to run your physical backup. But I want to make sure that we highlight that backups are still critical tasks. Even though I've replicated the copies to different pods, it does not keep you from needing to recover from a backup. So if you imagine the ransomware scenario that I mentioned earlier, they work because the attacker deleted the data. And the act of deleting the data was then replicated and happened on all servers. So without a backup, you can't recover that data, and you are forced to pay the ransom. For durability, then our databases typically ensure durability of the data changes when they flush that data to disk. They do it in some manner. So in systems like Postgres and MySQL, this is in a transaction log that's append only because it's faster to write data in a sequential manner, even with SSDs, right? So it's important that you make sure that your transaction logs are also stored on persistent volumes and hopefully fast hardware, that as fast a hardware as you can provide. So you also need to, for the durability, also, again, you need to make sure that these pods are replicated to different hardware and the data is on different hardware as well. For security, we have access control and an encryption piece, both at rest and in transit. For access control, you're just basically making sure that you maintain strong user control. So you don't have common maintenance accounts that have excessive administrative privileges to the pods, right, to the databases themselves. So that's kind of the typical user management. And if possible, you might start using a key management system to rotate the passwords and application accounts. But access control also extends down to the Kubernetes layer and the hardware layer where the storage is. So you don't want general access that an attacker can gain access to the pods or to the underlying storage. So you got to really kind of lock that down. And as a DBA, I'm going to be asking these questions to my security team to make sure that's set. Encryption in transit is represented by the lines in the diagram. So anything where there's access, basically network access, you need to make sure that all of those lines are encrypted. I will mention that encryption does have performance impact, but I'm not going to advocate for choosing performance over security in this case. So it's important to keep things encrypted in transit. And then encryption at rest are the solid things. So we're making sure that the persistent volumes are encrypted and the backups that we take are encrypted at rest as well. So that's kind of the security component there. And then on performance, it's kind of I would say this is the bigger piece that I'm going to be concerned about running databases on Kubernetes. Just because of the complexity. In my Venn diagram, I had the troubleshooting as a task that's done by all three categories, but the majority of the time, at least in my experience, is that's spent on performance troubleshooting. Think questions like, why are my requests slow? Well, this is latency. So Kubernetes is likely going to add more latency to my requests. And you might not know if this is something within the data itself on the pod, or because of some other pod stealing resources or some other reason, right? So you're adding a lot of complexity to answering the simple question, why are my requests starting to go slower? For scalability, the big question is, do we have enough capacity? Capacity of storage is pretty simple on Kubernetes. Capacity of compute resources of CPU and memory. And I think the bigger one for me would, even though I didn't list it in the other diagram, is do I have the network bandwidth between all of the components running on my hardware to make sure that network is not going to be a bottleneck on my database. I did mention that networking or databases are not very useful if you don't have networking, so you don't want to bottleneck that. So speaking of bandwidth, the question is there something wrong with the network? And the answer to that question is yes, of course, there's something wrong with the network, usually. But seriously, Kubernetes has a lot of additional complexity that we've already mentioned, and it extends beyond even simple virtualization. So your Kubernetes SREs need to have really good observability built in the system that you as a DBA can be able to plug into and be able to investigate why pod resource usage is the way it is. Are there bottlenecks? Are there starvation issues? Do we have enough capacity? Is there something stealing, right? All of the things I meant really comes down to having good observability. And I think that itself would be an interesting talk if there hasn't already been one. So yeah, that really brings me to the demo time, but do we have any questions before I do that?
I guess just taking in your case, because how long have you now been working as a DBA with Kubernetes?
Yeah, with Kubernetes, I have not had production. It's all like learning of how to do Kubernetes. I've done research and POCs, but never done production. And the main reason for that is, like I said, the persistent volumes were kind of a blocker for me. And I haven't been a DBA for several years. I've been focusing on DevRel and performance troubleshooting training type things.
No, that's fine. But I think also just what I want to say here is that because, we have a fair amount of young people in the audience, is I'd be curious to know is that, part of what in Kubernetes involves or demands from users is learning new things and unlearning old things. Would you say that that's somewhat true, that you kind of have to leave aside, this is the way we did it before, but now there's kind of a paradigm shift? I think that in some ways, perhaps I'd like to know, to what extent is that an advantage for new people that are starting out who don't bring that sort of legacy baggage along with them? What do you think about that?
Yeah, that's actually a really good point. If you are young and willing to learn and unlearn things, I absolutely agree. There are many people who are entrenched in the way they do things. I'll give an example. Like, this was kind of early on in not early, I was 10 years into being a DBA. That's about when RDS was coming out. I work at Google, but I can say Amazon. But RDS was just coming out with this database as a service, and I'm looking at the product and I'm like, there is no way this is going to be general enough that people are going to be able to use it, because there's so many knobs and specifics that your data environment needs, that you just can't generalize that on a product like an RDS or Cloud SQL. Obviously, I was wrong. I don't think I was wrong at the moment in time, because it was a kind of a DevOpsy release by Amazon, and it was not a complete product, but they didn't care. They put it out and they built and iterated and improved the product. So where they got to definitely had me thinking, okay, so I was wrong on that eventually. So now I'm going to be more aware later on of new technologies like Kubernetes that could disrupt the way I think things. And another area like that is generally automation. I'm going to sound like a really old guy when I say young people today have it so easy with the tools of Terraform and Ansible. They don't have to write their custom bash scripts or Python or whatever to manage their infrastructure. And so these innovations have made it a lot easier to manage. But if you previously wrote those things, then you're not going to be as likely to adopt an Ansible or a Terraform. And so, yeah, you absolutely have to have this mindset of later in your career, even now, early in your career, be willing to learn and be willing to challenge your assumptions.
Yeah, that's great advice. We got another question. Actually, we got a couple of questions. What is the most common issue if a database is running on Kubernetes?
I wish I could answer that with a production certainty.
But based on your experience,
it's going to be performance. The problem is I don't know what the performance is. Developers will come and add new queries that are slow, and then they're not using indexes correctly. But that has nothing to do with Kubernetes. I'm going to say that resource stealing, if you can't, like I mentioned in the talk, there's when virtualization was happening, DBAs said, no, I have to have dedicated hardware so I can prevent those virtualized environments from stealing my resources. But then advancements in virtualization came, and you could segregate and reserve and not get stolen. So I think that's probably true for Kubernetes as well now. It's going to be I spend a lot of time researching performance issues. And now I have this additional complicated underlying technology that I may not be 100% familiar with, but then I have to go spend more time trying to troubleshoot and make sure that I'm not chasing some sort of red herring. So observability, that's going to be the problem.
All right. Yeah. Okay, good. Let's keep going. And once we get more into the demo, I'm sure we'll get some other questions too.
Okay, so we don't have any more questions right now?
Yeah, for now, I think we did have one question, but it's more about DevRel, more career focused. So I'd kind of prefer to take that at the end.
Sure. Sounds good. All right. So for this demo, I'm going to go ahead and share my screen. I think I am on the Percona operator. This is the design overview. So if you don't know who Percona is, it is a company that provides open source products around databases. So they've done backup solutions for MySQL. They have their own flavor of MySQL. They have Postgres flavor. They have a Mongo flavor, things like that. So they are engineering environment and an ecosystem of tools around operating open source databases. And so one of the things they put out was this operator for Kubernetes. So I want to kind of walk through what this operator is. And this is kind of like what I actually do in DevRel, which is kind of to go to review a piece of documentation like this or a product, get my hands on it and go through the process, see what technically was out of date or technically was wrong, but also to see what kind of improvements that I might make. So it's kind of, you get to come along with me as I go through a friction process to improve this. Now, as a Google employee, I would do this for Google products. So I'm kind of doing this unsolicited for Percona. I hope they find it useful or not.
Shout out to Percona. Yeah.
I'm a big fan of them, but yeah. Let's see. So yeah, so hopefully as we go through this design doc, we'll be able to take away some of the things that I mentioned in the previous section. So right off the bat, I see my client application architecture. I have my proxy layer, and then I have my PXC pods. Now, PXC is Percona's XtraDB cluster based on a technology called Galera. Now, Galera is a rewrite of how MySQL replicates data. And it's important in this case because it's kind of self-healing. If one of these nodes goes away and then comes back on later, then these other ones will take care of transferring the data back to it and recovering that node without you having to write any application logic to do that. So Percona has their XtraDB cluster is a wrapper around Galera replication. So that's what PXC is. So I would hesitate to write any sort of database on Kubernetes that has no kind of self-healing component to it, like Galera does. MySQL has their own NODB cluster type or group replication product, right? So the reason for that is then you would, again, have to write the logic to handle the self-healing component if in case one of the pods stopped working. So they definitely have read and write from proxy. Now, and here they have their proxy SQL, which is a proxy layer that speaks MySQL protocol so that it can route read and write traffic to different nodes. Even though PXC allows you to technically scale your writes to different nodes, it still performs best if you have writes going to a single server, and then you can scale out your reads as you need to. And proxy SQL allows you to do that. So some of the things that they require, they definitely highlight that you have to have at least 3 nodes. And that's for high availability purposes that I mentioned earlier. And the load balancing, yeah, we just talked about load balancing. The high availability uses Kubernetes node affinity to make sure that you're running on separate pieces of hardware, as we discussed. And it can be recreated automatically. And then, yeah, they come down and they use persistent volumes that allows them to persist the data, which is super important for databases. Now, this is an area where I would, as I'm going through this, I'm going to go in and start researching what CSI is and all these pieces. If I'm definitely not familiar with it, but I imagine that these are key components to being able to run stateful data on Kubernetes. So I hope you're getting the sense that I am a DBA that doesn't know Kubernetes that well, and I want to go learn more about Kubernetes. All right, so the other thing this operator does is it will also add various layers. I don't think they talk about it, but they use extra backup to take backups. So they have different services. So they've created this operator that has the whole range of components needed to manage this MySQL data environment. If we look at the sideline here, we'll see that they have TLS security for encryption. They have actually two different ways to have load balancing. And then they have ways to reconfigure MySQL that you need to, and using environment variables and how to do backups. All of these things are important for running databases on it. Let's see what I am on time. So yeah, that's kind of, nothing jumps out at me from this operator that surprises me. If we go over to system requirements, we have specific versions that we need. The operator supports two different versions of PXC, which is 5.7 and 8.0. The one that I'm going to deploy is on 8.0. This is important just in case you need the right kind of version for your data environment. You can either have Google Kubernetes engine or Amazon's EKS. I'll be doing it on GKE, obviously.
So silly question there, though, Derek. But one of the things that we talk about a lot, is like portability, the importance of portability. And in this particular case, noticing that we don't see AKS, we don't see the Azure, Kubernetes service. Is that an issue then if we're trying to get an operator going in this case?
That if you're in an environment that needs Azure, then I would be surprised if this operator doesn't work on AKS.
Right. Yeah.
Right. Like usually these are kind of like similar APIs and they similar processes. I don't know enough about Azure to
No. It's not that you need expertise on that. But just
what I'm saying is, if it's not listed, it's a red flag. But that doesn't necessarily mean that it doesn't support it. It's just they don't have. It doesn't work. I would say that this is listed under the unofficially supported platform, officially supported platforms. So if you are using this, then you can go file a ticket and they will fix a bug or something like that, which they may not do with Azure, right? So, but I would be surprised if they didn't accept contributions or things like that. Remember, all of these things are open source.
Mm-hmm.
All right, and then resources. That'll just depend on. This is a kind of a quick install guide, right? So depending on what your data storage needs are and what your RAM needs are, that will change. All right, so I'm going to be bouncing back and forth between this tab and that tab. If you're not familiar with Google Cloud, the biggest takeaways from this top section is I will be using the G-Cloud command line tool. I've already performed these steps. One thing that I noticed when I first performed this on my Cloud Shell console, which we'll see in a moment, is that this command itself didn't work because of the way G-Cloud is installed. G-Cloud can be a package manager, but if you install it from a package manager like apt, then it's not going to manage packages. It's going to recommend that you install kubectl from your package manager like apt. So that wasn't in the instructions. So even with instructions like this, it's kind of fun to go through and say, okay, so you set this up from your environment and it worked fine for you. But from my environment, it's a completely clean install or something. Here are some issues that we had to work through, right? And so you're going to be expected to go through some troubleshooting. All right, and then the next line here is the command to create the cluster. I pre-did this because it takes a little bit to set up our cluster. I will highlight two components, which is the project. For Google Cloud to work, you organize everything within projects. Resources can be shared between projects, but every project has its own billing account potentially, but it's just a way in Google Cloud to organize resources. And then the other one is the zone. So I put it up. I did keep the US Central one, which is Iowa. And then I guess I'll highlight the different machine type that I use, which is N1 standard 4. This is providing enough resources that we'll see in a second for each node of the cluster. And I'm setting up 3 nodes. All right, so just a quick look of what that looks like. I'm assuming that that actually deployed correctly. So I said that I did this. I don't know that I actually completed. It's going to be a very short demo.
That's all good.
All right, so I reconnected that. I don't even know if that works. Container clusters. Container. See, you type on live and it's asking for permissions or whatever. So I do have a running cluster. This is something that I might take back and say, hey, why don't I have a way to refresh this clusters UI? So that's refreshing. And now I probably have to bring up my shell again. So there's my cluster right there. I have to turn on my shell again. I have 3 nodes each, or in total, I have 12 vCPUs and 45 gigs of RAM. Helpfully, they tell me that I have low resource requests, which means I'm not using my cluster at all, which is great. I like that because they're telling you that, hey, you may be over provisioning your environment. So save some money by not having that if you've actually got load on your cluster. All right, so next up, after I have my cluster, I need to install, let's see, I need to actually allow myself to, I actually have to allow myself access to this cluster. So first of all, I'm going to set my project environment variable. Now I'm going to get my credentials for the project so that I can work with the cluster endpoints. And then I'm going to allow my own personal user is the next step of this to be able to manage the cluster. So that's the purpose of this next command that I'm running right now. All right, so now my user can manage this cluster. Next up, I'll need to create a namespace. Namespace, does anybody know what namespaces are? Will I do this?
Enlighten us.
Namespaces are a way to logically separate, organize your overall Kubernetes cluster. So for the purpose of this, I want a namespace for my PXC environment, which I have now named DoK demo.
Ooh.
And then I need to, actually it tells me that I need to set this context for the namespace. I'm gonna just see what happens when I skip that, because that's kind of what makes fun things. All right, so I need to get into my previously downloaded Percona thing. And then the next step on this is to go ahead and deploy the operator. Now I'll go ahead and run this command. And it's basically deploying the allowed services that this Percona operator will handle. If I kind of make this a little bit bigger, I can go through some of these things. We'll see various things like the endpoints that I need, the various service storage requirements. I will have PXC. I see proxy SQL here, which is that one load balancer option. I have HA proxy. So basically, it's just a list of the different things that the operator services that it provides, as well as how it interacts with all these different things. So I've pretty well oversimplified that, but the operator, that's the purpose of the operator. All right, so now I have that. And now I want to go ahead and deploy my deploy my cluster. And so that is what the CR YAML is. This will take a couple minutes. So let's kind of look at what we're deploying here. All right, so I'm deploying cluster 1. I'm saying I need 1.9, or that is the operator version. What else do we have in here that's interesting? Checking for upgrades for the Percona packages. PXC, I have 3 nodes. These are the images that I'm using. I do want auto recovery because it's Galera, and those are interesting. A lot of different things are commented out. We'll see that the configuration is commented out, so it's really kind of doing defaults, but there's obviously a way to provide configuration that I need to modify. What else do we have here? Tell me what kind of resources that I need to request from the Kubernetes cluster. Yeah. So we'll see that it has uncommented HA proxy. So I would expect that doing this, I'm going to be going to have 3 HA proxy nodes for high availability and the 3 PXC nodes. So if I do a, what is it? CTL get pods, let's see our status. So yeah, I have a HA proxy node, I have a PXC node. It's going to take a minute to provision everything. So if I kind of minimize this a little bit, do we have any questions while this is running?
Let's take a look. So it looks like so far so good, but it is interesting because it's nice that we're doing this because a lot of times we're talking about data on Kubernetes, but we're not actually necessarily seeing an interface about how it works. So I think that just for starters of getting more tangible visuals is really, really helpful because sometimes it sounds like we're talking about something that exists on another planet, but to actually see it face to face, I think is nice and healthy. And also seeing in there, could you maybe quickly explain what a stateful set is?
No, I can't. But I can take a guess. A stateful set to me would say, look, I need this pod to be tied to a specific persistent volume claim, right? Because if this pod goes away and moves somewhere else, I need the data to be accessible somewhere else. Am I close?
I think that is quite close. And no, because it's one of those things that we've talked about stateful sets before in our community. So yeah, it's manages the deployment and scaling. That's what you see below that too. You see the deployment. So it manages the deployment and scaling of a set of pods, and then gives guarantees about where the ordering and uniqueness of those pods. So basically like the workload API object that's used to manage stateful applications. I say that just because one of the core fundamental things of our community is talking about stateful workloads, applications, et cetera. Yep. So stateful sets is definitely a big thing that we talk about a fair amount.
Absolutely. And like I would be hesitant if they didn't have the capability to handle stateful workloads. So that to me, that's just tying the state or the data to the pod, right?
Mm-hmm.
All right, so I'm starting to get some additional nodes here. If I refresh the UI, which is cool, I have the workloads refresh button, but I didn't have it in clusters. It's saying that I have 3 pods available for HA proxy and currently 2 for PXC. I think that's enough for me to continue on. So the next part of this thing is to get the secrets. Specifically, when this was deployed, we've generated some passwords that I need to connect. I need the root user, for example. And so kubectl allows me, since I'm an admin, to get the secrets for the cluster. I will note that I did skip this step up here where it said set context for the namespace, and nothing has broken yet. So I don't think that's necessary. It's fun to try to break things like that. So I have my root user here. Now, the first time I did this, I didn't actually read the documentation. So I started using this password. So it's important to read the documentation sometimes. The problem is that this password is base 64 encoded. So that's good. It's encrypted within the kubectl. So I have to go ahead and decrypt it. Although the decode capability, anybody seems like they could run it. So I don't know how secure that was. Let's see what else I need to do. So I've copied that password. All right, now I'm going to run a Percona client.
Oh, we do have another question.
Okay.
So the question says, I'm wondering about the maintenance part, such as major or minor upgrades. Will it be more difficult compared to upgrade the database running under a VM compute engine?
Yeah, it's so performance version upgrades or patching, whether it's minor version or major version from like 5.7 to 8.0 in MySQL, has implications on security. Like I mentioned, there might be a security vulnerability that's patched. Availability, obviously, because of ways that things like if you're running an old version and you're trying to do zero downtime upgrades, you want to do zero downtime, but then you may not be able to because of the version compatibility. So if you have to schedule a maintenance window, so that's that. But the weird thing about upgrades is performance, right? It's faster, I think, to just on Kubernetes go provision a new node that has the upgraded version of the image that you're running. So that part is faster than doing on a VM. But the piece that doesn't change is you have to do some performance regression testing of the queries that your application is sending to the database, that your schema is compatible, that no new keywords were added to the syntax that all of a sudden break your queries or things like that. So you got to still do functional and performance testing of upgrades, and that does not change. It doesn't get any easier, at least with Kubernetes.
Perfect. Thank you.
Yeah, so it turns out if you use the copy from a Mac on Windows, it doesn't work very well. So as part of my job, I switch between Windows and Mac, and I still get command copy, control copy different. So what this command is doing is basically spinning up a new pod of a specific image that is basically got the client tools pre-configured. So it dropped me into this bash command line of this Percona client image. And now I need to decode my root password. And then that's that. Normally, I would hate to show you my root password, but this cluster is going to go away soon. All right, so and all I'm going to show here is a couple of things when I connect into the MySQL command line using these. Root. All right, so real quick, I'm trying to make this a little bit bigger. I'll do a status of the node to show that I'm connecting from root. I'm actually connecting remotely from root instead of a local host pod. You'll see that I'm coming from the HA proxy cluster. So I'm actually routing through my load balancer. Normally, I would be concerned about being able to connect remotely from root from a security perspective. So that would be something I immediately would lock down. I would not allow root from outside the HA proxy, and I would require connecting into the actual PXC nodes. Personal preference from a security standpoint. I'm also using a encryption, AES 256. That's good. those are the main. Oh, and then MySQL, basically 8.0 minor version, using the Galera WSREAP replication that I mentioned earlier. All right, let's see. Let's just quickly look at the users that are permissioned. So this operator by default installs a couple of different users. It has a monitor user, it has an operator, replication for the pods. It has my root from anywhere. That's what the host pattern is for in MySQL. It has a backup user, and then it has a cluster check utility that can check in there. When I'm looking at users from a security perspective, I'm kind of looking for grants. So like if I look at my current user, I can pretty much do anything on the database as a root, which is something that I would expect to do, right? And so, like I said, I probably wouldn't allow it remotely from anywhere. I would at least lock it down to the IP range of the cluster if I could. Let's look at our monitor. Show grants. All right, so here, monitoring the database, we are restricted a little bit more on the permissions. So it's good. It still has this super privilege, which is kind of a broad range of scope for a monitoring thing where I would expect I can only grab things. So I would dig into why exactly my monitor user needs grants. So yeah, I mean, there's a lot of different things that I would look at on the users that are provisioned. It's good that they've provisioned different users for different roles, because from a security perspective, I can come in and audit who's doing what. And I would try to restrict things where I couldn't, using the principle of least privilege, which basically says only have the privileges that you need and no more. Yeah, that's it for the demo, I would say. Do we have any questions? I know we're over time, but
oh, that's all good. I did want to get to the question that someone asked earlier. Well, actually, but before, can we to wrap this up properly for, once again, folks that are out there that are just getting started, by the way, amazing talk to get all this groundwork down there. I think for a lot of people, whether it doesn't matter if it's Kubernetes or learning, I don't know, anything that's complex, nobody wants to feel stupid, and so to sometimes just to get people to actually be thinking about like, all right, I want to take the first step. What's the first step? In terms of resources for people that are really, true beginners that are out there, what would you recommend? Saying, if I were you, I would definitely do this.
Yeah, don't go and learn a specific technology. I mean, yeah, do that in conjunction. Start reading some things about areas of the industry on how people operate it. The two books that I would highly recommend in this space are the Google SRE book, which gives you a lot of good concepts and frameworks to work with any technology, really. So it's tool agnostic. So there's that one. And then if you are interested in the subset of information around database reliability engineering, I have it here somewhere. Yeah, there it is. The database reliability engineering book from O'Reilly, right? So this takes concepts from the SRE book and applies it to the database space. So both of those are really good. And I highly recommend reading about how people do things and why people do things that way. To the earlier point that that you may have to unlearn some habits down the road when technology shifts.
No, I think that's good. I think also what you said too, I think it's interesting about, and something we're also trying to focus on in the community, the end user. So see, like once this technology is actually being applied in a specific context, what are the benefits that it's providing? What is the value that it's adding? And to understand not just the what it is and how it works, but why it's being done. I think that's a good way to keep that in mind. But I think also with something as well too is, you just mentioned a couple of books. for people that are out there that are learning, don't overwhelm yourself in the learning process. It's going to take time. Yeah. You don't need, because, and we even sometimes, there are some exhaustive lists of like all these different Kubernetes resources. And it's good to know that there's a lot of stuff out there, but I don't want people to feel that they need to do all of that. Start with one thing, get some background. It's going to involve some reading. It's going to involve some listening. And then it's also going to involve some practice. So that's the other thing, is find a way, find an excuse to practice it, whether it's in our community, a SIG in the CNCF, I don't care what it is, but find somewhere where you can actually put this stuff into practice. And that's where you'll get more questions as well too. Yep. So that's good. Now, to address a previously asked question, for someone who's interested in starting to work in DevRel, any recommendations that you would have there?
Yeah, so DevRel. So I'm going to address that as I close up this last thing.
Okay, cool.
Which is interesting. It says keep learning, definitely, like what we were just talking about.
Yeah.
DBAs, they're guardians of the data. Anybody in tech needs to keep learning. But DBAs specifically, they need to learn the new technologies to protect the data better. Yeah, keep learning, which leads me into DevRel. First, get a mindset around always wanting to learn. To Bart's point, don't overwhelm yourself. Do a couple things, practice, do more. Find communities, though, is the thing that I would say is go in and start contributing. DevRel is different to a lot of different people, but you can be a DevRel giving talks. I think I froze.
It's okay.
My video froze, but I'm still here, I guess, on audio.
Yeah, maybe turn off your camera, turn it on again. That sometimes works, but if not, just keep going. We're
yeah,
so,
it's
all good.
Yeah, so hey, it worked.
Yeah,
okay.
It did.
So go find yourself in communities that you can get involved with and help. Be respectful, because like you don't want to go in and say, look, I know better how to do this than you do, who are the people who created the product. You want to be the ones that are coming in. I'm here to help. What do you need? Right. So be a little bit humble, be a little bit willing to get your hands dirty. And yeah, but be helpful. Right. Some of the DevRel things that I do are blog posts. I do these talks like this about different products. That's not always what you have to do. Like just if you want to blog, start blogging. If you want to promote a product, go find out how the maintainers of the project want to be promoted and see how you can help that way. And just get involved. Don't use an excuse that I don't contribute code, or I don't do X, Y, or Z.
And don't use that stuff. Yeah, we've had those conversations time and time again about imposter syndrome and prerequisites and things like that. Like you just said, is the best way to get involved is get involved. So just the only thing you should be have to fear is fear itself. Get out there and ask questions. If you're friendly and have a positive attitude, you make it pretty difficult for people not to help you. So it shouldn't be too difficult. Good. Any other closing pieces of advice?
No, I mean, like these are really good questions, and I'm really glad to see a community Bart like this where they're highlighting the need to learn new things and practice. Like, so just those two things: learn, practice, ask questions. Don't hesitate to ask questions, and just go have fun with it.
Yep, very, very well said. Lastly, I'm sure everyone's kind of wondering, if they want to get a job in Google, what's the best way to go about doing that? It sounds like there's a really clear, easy answer to that. So start investing in cool hats.
Yeah, hats. No. I mean, early on in your career, you are going to have to know how to software engineer. It doesn't matter what role you have, even in DevRel, you're going to be expected to be able to software engineer because you need to be technical. Yeah. I actually applied many years ago in Google and couldn't even get past the phone interview because I didn't know what package manager Perl was using or something like that. So that was kind of humbling, and I didn't let it bother me. And, years later, I was able to find my niche, and I have the background and experience, the willingness, the passion, all of that stuff. So get that. and Google will find you.
I think that's a really nice way of putting it, though, is that if you create that sort of context by paying it forward, by being active in communities and things like that, it's not so much you having to find the companies, that they'll find a way to, it's their job to kind of find you. I think it's a nice way to put it. And also, you know, don't take no for as an answer. And it's funny that we're talking about persistence so much, but the human nature of persistence, you must be the persistent volume claim that carries over from one instance to another. Oh, we're getting very poetic and philosophical with the infrastructure. But really, I think that's a great point. And to understand that, you know, this is a journey and there are going to be many stops along the way. Be proactive, engage in different communities, be patient. It would be wonderful. I don't know how many, you know, 20-year-olds get jobs in Google. Maybe there are some, I'm sure there are some. But generally, you know, you may not get it right the first time. So just keep that in mind and be proactive.
Going.
That's it.
Yep.
Derek, if folks want to follow you on Twitter, how should they do that?
Yeah, my Twitter handle is Derek_Downey. Feel free to follow. My DMs are open if you have any questions about Google or databases or anything, really. Happy to answer questions.
Perfect. Great having you with us today. Thanks so much for joining us last week as well in Twitter Spaces. Getting some very nice comments in the YouTube chat. A lot of people learned a lot today, and this is going to be a great go-to resource when we have new folks coming in the community, because of how well it lays everything out and how not overwhelming it is from a technical perspective of getting all the different pieces and seeing how they build towards the demo that you did too. So anyway, thank you very much, Derek. Very, very lucky to have you with us today.
Great. Thanks, Bart. Had a great time.